Okay, you finished 1.2 and you've done the quiz, and we're moving to 1.3. And initially, I said that these three young people were fundraising, and so they in 1.2 they figured out how many meters they walk per second. They were checking their walking rate, and now they're organizing what they're going to do for their fundraising. So, like I said, it's going to be a walkathon. And each of them has decided to collect donations from their sponsors differently. So when you're doing a fundraiser, if you're doing a walkathon, what you're doing is you're walking a certain amount of, we would do miles, they're going to do kilometers. So they're walking a certain amount of kilometers and they're saying, so you're going to give me money, you're going to sponsor me, and then I'm going to use that fundraising money and I'm going to donate it to some sort of cause or project or whatever. And so Leanne decides no matter how much she walks, her sponsors are just going to donate $10. So if she walks 1 mile, they're going to donate $10. If she doesn't walk at all, they're going to donate $10. If she gets sick that day and can't walk, they're still going to donate $10. If she walks 100 kilometers, they're still just going to donate $10. So when you're writing the equation, y is the money they donated, how you figure out how much money they donated. So in Leanne's case, they're just donating $10. They don't really care if she walks and how far she walks. Gilberto is a little bit different. He's saying, well, it's really a lot different. He's saying that he is going to collect $2 for every kilometer he walks. So when he walks 1 kilometer, they owe him $2. If he walks 10 kilometers, they're going to have to donate $20. So they're saying, and it's a lesser money, right? It's $2 rather than 10, but they don't know. If he walks 20 kilometers, it could be that they're going to owe $40. So it's $2 per kilometer. So that means 2 times the distance he walks, how many kilometers he walks. Alana says a little bit different. So she's saying, well, I want to get a minimum of $5. No matter what, everybody that sponsors me has to pay at least $5. And then for a little bit extra each kilometer, they can chip in a little bit more. So I'm going to say, you're going to definitely give me $5 plus for every kilometer I walk, you're going to give me 50 more cents. So if I walk 1 kilometer, you're going to have to give me $5.50, $5.50 for that 1 kilometer. If I walk 2 kilometers, you're going to have to give me $6 because that's 2 50 cents, so that's $1. And I have to add that dollar to that $5 initial donation. So no matter what, even if she doesn't walk, everybody has to give her $5. And then for every kilometer she walks more, okay, then she's going to get 50 more cents. I want you to listen to the language I'm using because it's going to make a difference when you make the table. Remember I said in 1.2, you need to have that zero amount. And they're going to, again, have you make a table. And it says specifically 0 to 6 because that 0 level, that 0 kilometer piece is really, really important now. Okay? Listen, if Leanne doesn't walk at all, they still have to pay her $10. They're still donating $10 because they said no matter how far she walks, including 0 walking, okay, they have to give her $10. Gilberto is $2 per kilometer. So if he doesn't do any kilometers, he's not getting any money because he has to walk to get money. Alana's getting $5 before she ever walks. She's getting 50 cents more for every kilometer. But if she doesn't walk at all, those sponsors are still giving her $5. So when you do the table, make sure you're very careful in what you put in that 0 kilometer section, how much they're going to collect if they don't walk at all, if they walk 0 kilometers, because it's going to make a big difference. When you do the equation, make sure you understand what you're saying. So Y is going to equal the total money they donate. Okay, and so I have that written down right here. And so what you're going to put here is how they're going to get that total amount. Okay, so I would, make sure that you're looking carefully at the wording in each of those situations for Leanne, Gilberto, and Alana. You're going to graph this also, and make sure you're careful when you're graphing. Remember, if a point is 0, where the kilometers are 0 kilometers, and when you're doing the graph, make sure it's staying exactly like it was in the other one. It's going to be kilometers are going to be, the distance is going to be at the bottom, okay? And the X is going to be the money they're collecting, okay? So you want to make sure you got the X and the Y correct, okay? The money depends on how far they walk, okay? So those are your two variables. So if I walk 0, will I still get money? Because then that's not going to be at that 0 point. Okay. I think the one that I think gives people the most trouble in this whole investigation 1.3 is B3. And it asks you to check if a point satisfies an equation. So you're going to have 3 equations. You're going to have Leanne's equation, you're going to have Gilberto's equation, and you're going to have Alana's equation. And they're asking you if 12, 11 satisfies the equation. Does it make the equation true? Okay, so let's remember that this is going to be the 12 is the X. So that is going to be kilometers. That represents kilometers. And the 11 represents the money they're collecting. Okay, so you're looking at each of those equations and you're saying, if I go 12 kilometers, will for one of these people, one of these young people, going 12 kilometers means they're going to collect $11. And which equation is going to satisfy that? So you would substitute in that 12 into the equation and see if the money collected is $11. Okay? So you're going to do A and B. We're not going to do C, but I want you to do A and B. In the quiz, you're going to be asked about linear equations, and again, you're going to decide if something's linear, and if what the pattern of increase or the rate of increase is. And you're also going to be asked that in problem B and A and B. They're looking for the pattern of change or the rate of increase. They're both the same thing. What is the change every time? What am I increasing or decreasing? What is the rate of change? What is the pattern in the table in each of the relationships? I just want to do this one over here on the side, okay? Just kind of an example, a little bit past the B3. So here would be an example. If the X is 8 and the 4 is Y, I'm going to look and see which of these works out. So if the X is 8, I would say over here is if this X is 8, is 8 plus 4, 4. Then I'm going to substitute them in. No, that isn't true. Not true. Okay? How about if this X is 8 in this equation? Well, is 8 times 4. 4? No. So now I go to this last equation. I say, well, if x is 8 in this equation, will y be 4? So 1/2 of 8 is 4. And so that's how you check, okay, the whether a point fits into an equation. You have to substitute in. You take the x and you substitute that x for that number, and then you solve the equation and see if you get the y as the answer. Okay, I think I've given you enough stuff. We're going to see how this works out. So go ahead and let's start 1.3.